In this video, we are going to learn vector equation of a plane. For vector equation of a plane, first thing you have to know the formula. This is the formula. R dot n equals A dot n. So first thing, sketch the plane. Okay, this plane named as plane pi. So plane pi. Okay, plane pi consists of n and a vector which is perpendicular to the plane from 90 degree here, and A lies on the plane. Okay, A represented by coordinate A1, A2, A3. R is any point, it also lies on the plane R. So for a vector equation of a plane, okay, the important is to find n. N is a vector perpendicular to the plane, means that we need to do cross product between the two vectors. Okay, the two vectors suppose lie on the plane or parallel to the plane. Okay, let's say this is a vector P, vector Q. So vector P, vector Q, vector P, vector Q, do the cross product, and the product suppose perpendicular to vector P and also perpendicular vector Q. This is called n. So find n. Okay, here in this video, I'm going to discuss in 4 cases. Okay, first, if the plane contains 3 points, find the vector equation of a plane. R dot n equals A dot n. So first thing, okay, write down the plane. So here 3 points. A, let's say A, B, C. Okay, we're going to find vector equation of a plane. So for A, you can take point A or point B or point C. Okay, but to find n, vector n, you need to cross product the two vectors. So from the given 3 points, okay, find the vectors, join A to C to become vector AC. And as a line, take this one to B. Okay, to find vector AB. Okay, so here is vector AB cross vector AC, and to find a vector which is perpendicular to the plane, that is n here. Okay, and substitute here, do dot product, and you get the vector equation of a plane for this case. The second case is given 2 points and a line which is parallel to the plane. So this is visualize the plane pi and write down the equation of a plane. Okay, so 2 points. Let's say the 2 point is A, B. Okay, and the vector is parallel to the plane. Let's say this is the vector L, the line L, which is parallel to the plane. Okay, I mentioned that this line is a line on the plane. You just say that parallel to the plane. Okay, so here for A, you can take coordinate A or coordinate B. Okay, problem now is to find n. Okay, so to find n is a vector which is perpendicular to plane. To find n, you need to do cross product between the two vectors. Join A to B to get vector AB. So get vector AB, you need to find another vector so that you can do cross product. So from the info given, line L, okay, this is the equation for line L plus TV. Okay, different A. So for L, we give direction for L, and V, okay, V parallel to L, and maybe V is line on L or outside L, but parallel to L. So we take V here. Okay, the vector n, which is perpendicular to the plane. Then substitute n and get the equation of a plane. So the third case is a plane if given a point and a line, okay, lies on the plane. Okay, write down this one. So given a point and a line L lies on the plane. Okay, so to find an equation of a plane which contains a point and a line, so you need to write down the formula. Still need to write down the formula of the plane. Okay, so here you can see A clearly, the A here. The problem is to find n. Okay, n with a vector which is perpendicular to the plane. So you need to do cross product between two vectors. Cool. So here, L, the info given is L. L is R equals A plus T V. L lies on plane. L here has a point. This point is I call B. Okay, B here, and also vector V. Okay, this vector V. Okay, give direction to the line. So this is vector V. You can take this vector, one vector. Another one is you need to find here one more vector, which is lying on the plane. Okay, so there is no info for a vector, but the info is one point A lies on the plane, and B, coordinate B, which is lies on the line and also lies on the plane. So join the two points to get vector A, B. This is vector A, B. When A and B lie on plane, this vector AB also lies on plane. So do a cross product between vector V and vector AB and get vector N, which is perpendicular to the plane, then substitute and find a vector equation of a plane. Case 4, plane contains two straight lines, L1, L2. Find the equation of a plane. So just sketch this one. L1. L1 consists of R1 equals A1 plus TV1. Okay, so for L1, here is 1 point, A point, fixed point. Let's say this is coordinate A, lies on L1 and also lies on plane because of plane contains the line. Okay, and this is V1. V1 give direction to L1. So for L2, this is fixed point. Let's say this is B, coordinate B here, and V2. V2 give direction to L2. Okay, so here point A, point B. Okay, point A lies on line L1, point B lies on line L2, and both L1, L2 lie on the plane. And also that point A, point B also lie on plane pi. So here you can choose either point A or point B. Okay, now problem is to find N. N, you need to find vector N. N is a vector which is perpendicular to the plane. You need two vectors, do cross product to find N. So here, V1, here also V2. Just take V1 and V2, do cross product and get N. N is a vector which is perpendicular to plane and substitute and find a vector equation of a plane. For a vector equation of a plane, R is represented by X, Y, Z. This is N, A, B, C. And you do dot product between vector A and vector N, you get the scalar. Say that this is P. Okay, so do the dot product on the left hand side. You get AX plus BY plus CZ is equal to P. This one called Cartesian equation of the plane. So when talking about plane, either you leave the answer in vector equation of a plane or with Cartesian equation of the plane. Okay. From the above discussion, I hope you understand and know how to find the vector equation of a plane.